Our seventh video lecture in discrete math, and for today I would just like to give a few examples on proving arguments using our rules of inference together with our rules of replacement. So just a quick review under rules of replacement. If you will go back to your module, we have a total of 14 rules here. Okay. Then after the rules of replacement, we have considered last time our rules of inference. And under rules of inference, we have listed down 9. And under rules of inference, we normally use this in considering arguments. And when we say we are having an argument normally will be composed of two parts. We have our premises, and then we have our conclusion. And we have said that an argument will be valid if each premise will be true, or all the premises will be true, and the conclusion is also true. Okay? So if you are wondering what's the main difference when we use the rules of replacement, when to use the rules of replacement and when we use the rules of inference. Going back to your notes, basically when we were using the rules of replacement at the first section, we have considered logically equivalent propositions. And under logically equivalent propositions, like in math, it's similar to equations. You have the left side and you have the right side, where you now try to show that one side of your proposition is equivalent to the other side of the proposition. While for the rules of inference, you normally use this when you are proving arguments. And the format of an argument is you have your premises and then you have your conclusion. But if you will really look at these two carefully, arguments actually can be written also as logically equivalent propositions. How do you do that? You just connect all your premises together using your conjunction end, and that should now be equivalent to your conclusion. So they are just similar. Now, in terms of the use of your rules of replacement and rules of inference, proving your arguments, if you are still confused when to use the rules of replacement, when to use the rules of inference, if you will look at your list, normally, you use the rules of replacement if you are only considering one line in your argument, or you are just considering one premise in your argument. On the other hand, if you are going to use the rules of inference, normally, for the rules of inference, you use two premises so that you come up with a conclusion based from those two lines or based from those two premises. But what you obtain now is added as a new premise, unless you already obtained the final conclusion. Of course, the only exemption is when you are using addition and simplification, because under addition and simplification, there's only one line for each rule. Okay? So let's now get into business. Let's prove some problems today. And let's start with this very simple example. Prove the argument that P implies not P therefore not P. Okay, so we only have one premise, and then we already have the conclusion, therefore not P. Looking at our premise, P implies not P. We want to obtain not P. Since we only have a single line to use here, then we now go to the list of our rules of replacement. And what particular rule of replacement will you verify in your list? Since you have an implication here, since you have a conditional statement here, go now to your list and look at a rule that will now use an implication. And if you will go over your list, you will find there the rule that mentions material implication. And the material implication states that if you are given, let me just state the propositions given in your notes. You have P implies Q is equivalent to, you negate the first one, that should now become not P, and then or Q. But if we will now use it here, what we get will be not P, or since our Q is also not P, so we write here not P. So what did we apply here? Material implication of premise number 1. So this now becomes a new premise. Not P or not P. Our conclusion is not P. Not P is already here. But we have two not P's with our connective or. So go now to your list. You will be using only one line. So most likely you go to your rules of replacement. And under your rules of replacement, what rule will you find that uses this one? You will now find that this is equivalent to your idempotence. Look now at your idempotence rule. And under the idempotence rule, it states that if you are given P or P, it is equivalent to P. Thus, not P or not P is equivalent to not P, which now gives us the conclusion. So that ends the proof. So the first thing that we have applied is using material implication. We're only using one line here. So using material implication, we have P implies not P. Material implication is P implies Q is equivalent to not P or Q. And then, since our Q is also not P, we can now use idempotence. Not P or not P is equal to not P. Then that ends the proof. Second example. Second example is we are given the first premise, not P or Q. Second premise, we have R or S implies P and not Q, with the conclusion not R. Okay, so how do we start with our proof? Let's first analyze our premises given. So we have not P or Q, And then the second premise is R or S implies P and not Q. Our conclusion is just the proposition R. Of course, it's not R, but what I'm pointing out here is we only have a single proposition here, which is proposition R. Proposition R in your premise or in your premises is found in premise number 2. So this means that we want to get rid of our P, Q, and S. We need to get rid of P, Q, and S. So that will now be our problem. And how do we do that? Look at the second premise. We have R or S implies P and not Q. This is an implication. The second proposition, this is considered as a single proposition. The second proposition is having the same propositions with the first premise. We have the propositions P and Q also involved. So how do we get rid of this? Since we want to use 2 lines, so most likely we will go through the list of the rules of inference. And under the rules of inference, since we are looking at the second part of this conditional statement here, and we are comparing it with this proposition here. And in your list, modus tollens has a conditional statement, and then the second premise is a negation of the second proposition of the first premise. Okay? So, if we will use modus tollens, go now to your list of modus tollens. Your modus tollens states that P, so this entire thing here will be considered as your P. P implies Q. The second premise must be not Q, so that you get the conclusion of the negation of the first premise. Did you see that? So modus tollens again. P implies Q. The second premise must be not Q, so that your conclusion is not P. And we want now to get the negation of this. And how can we produce the negation of this? Go now to the first premise. The first premise, to get the negation of this one, we can apply, this is now a single line, so we can now apply De Morgan's rule. And using the De Morgan's rule, we now obtain not P and not Q. Isn't it? If you use the De Morgan's rule, you negate the entire proposition, then you change the connective from or to end or from end to or, whichever appears in your given expression. So, this is using De Morgan's rule for premise number 1. And let's call this as premise number 3. Then using now premise number 3, we have obtained already the negation of this one. Since we have already obtained the negation of this one, then we can use modus tollens. P implies Q, not Q must give us not P. And not P will be not R or S. So what's this? This is modus tollens of premise number 2 together with premise number 3. Okay, what's our target conclusion? our target conclusion is not R. Now, we have here R or S, but the entire thing is negated. So, applying again the De Morgan's rule for line number 4, we get not R, that now becomes and, not S. Okay, we want not R as the conclusion. This is a conjunction. We can now use simplification. So this is just a single line. So if you will go to your simplification rule, anong sabi sa simplification rule? P and Q, therefore P. So we can now have not R as our conclusion. This is using simplification of line number 5. And after simplifying line number 5, we now obtained the desired conclusion, which is not R. So that's example number 2. Another example for today. Another example is, let's say we have P or Q implies S. This will now be premise number 1. Premise number 2, Q or P. And then our conclusion, or we still have a third premise. We have S implies R or Q or W. Conclusion, therefore, W or R or Q. W or R or Q as our conclusion. Okay, let's analyze this. So we have 3 premises. This is our conclusion. Let's examine. So what we desire to come up with is a proposition involving W, R, Q. And where do we find those propositions in our premises? We find it in premise number 3. In premise number 3, you will find here your W, your R, your Q, and they are all together. And if you will look at the connectives in this section, similar already with the connectives in our conclusion. Okay, so it means we want to obtain this. And in line number 3, in premise number 3, you will find here that you have S implies a proposition, or a proposition implies a proposition. So what will be our target? If you will look at your list of rules, an implication in your rules of inference, particularly your modus ponens. What does modus ponens tell us? It says that if you are given P implies Q, P, therefore Q. So, we want to get another premise that will just involve S. And where do we find a premise that involves S? We have it here. So we want to get this S proposition here. But what do we have? We have P or Q implies S, and we have here Q or P. Isn't it that these two are just the same? So what can we do there? We can first, if you want, you can interchange P, Q there. So that's the same as P or Q. This is just what? We're just applying commutativity. Commutativity of line number 2. Then after applying commutativity of line number 2, you can now use, look at this, you have P or Q implies S. You have P or Q. Isn't it that if you combine premise number 1 with premise number 4, that is your modus ponens. Anong sabi sa modus ponens? P implies Q, P therefore Q, right? So that's an exact representation of your modus ponens. Therefore, this now gives us P or Q implies S. The second premise that we're using is P or Q, therefore we get S. This is modus ponens of 1 and 4. So there you go. That's what we want to come up with. The proposition S. S implies something S. So again, modus ponens. So this time, using modus ponens of line number 3 and 5. So applying modus ponens of line number 3 and 5, we get R or Q or W. Okay? Oops, that should be number 6. That should be line number 6. Sorry. So we have R or Q or W. What's our conclusion? Our conclusion is W or R or Q. Okay, since we have similar connectives here, we can just use the associativity rule. Associativity rule, since we have similar connectives here, we can just rearrange the elements and we get the same result. So we have W first, W or R or Q. This is just using associativity rule for line number 6. And there you have it, the conclusion of the expression. Okay, so that's the third example that we have. Next, fourth example, we have the first premise, P and Q or R. Second premise, not, I think this was the example I have given also earlier. No, it's not. Okay, so we have not P or not R. Let me just check. Okay, that's a different problem. Going back to that example. We have P and Q or R. Second premise is not P or not R. Conclusion, P and Q. P and Q. Let's examine. Let's examine. Our conclusion is P and Q. Where do we find P and Q? In premise number 1. You don't find Q in the second premise. So most likely, we will be able to obtain P and Q from the first premise. And in doing so, what can we apply first? Look at this. You have P and Q or R. So what can we do here? We can distribute P first. And in distributing P, we get P and Q or P and R. What was that? That's just distributivity rule in line number 1. So this will now be called the third premise. So that's the third premise. We have P and Q. We just distributed P and Q or P and R. Then from there, what can we do next? We have, let's look at the second premise. What do we have in the second premise? We have not P or not R. Quite similar to this one. We have P and R. So how do we get a P and R expression here? Look at this. If we will use De Morgan's rule in premise number 2, De Morgan's rule, we can bring out the negation sign or the negation connective. That becomes P and R. This is just De Morgan's of premise number 2. And after using De Morgan's rule in premise number 2, look at what we have obtained here. We have P and Q or P and R, not P and R. And P and Q is what we desire as our conclusion, P and Q. So we need to get rid of this. And go now to your list. We are using 2 propositions here, or we are using 2 premises here, and we want to retain this. Look at your list. What can we use? This is an or. This is a negation of one of the propositions here. And you will find this under disjunctive syllogism. Number 6 of rules of inference. Disjunctive syllogism. The disjunctive syllogism states that P or Q, not P, therefore Q. So, we can actually interchange this. So you have, it's commutative because we are using the connective or. Anyway, we may skip that part, and instead we can proceed to using the disjunctive syllogism again. Disjunctive syllogism states that P or Q, not P. So in this case, we use not Q. So what will be our conclusion? It will be this part here. P and Q. So this is just using disjunctive syllogism. Excuse me. Disjunctive syllogism of line 3 and line 4. And because of the disjunctive syllogism, we now have obtained the conclusion. So that ends example number 4. Next, can you still take one example? One more example. We have, this is quite long. Premise number 1. T or P implies W. Premise number 2, not W or S N I. Premise number 3, not S or not I implies not E. And then we have not V implies E. And number 5, we have not V. Conclusion, not T or P. Okay. Where do we find our conclusion? We have T, not T or P. T or P is in the first premise. So most likely we will be obtaining our conclusion from premise number 1. T and P. Therefore, propositions T and P must be left behind. So what do we need to get rid of? We need to get rid of W, S, I, and E. W, S, I, and E. So where can we start? Look at here. I think the last two premises are simpler compared to the others. This is an implication. We have the same propositions here, right? This is an implication. So we can have modus ponens for 4 and 5. And if we will use modus ponens of 4 and 5, that will just leave us E. Modus ponens of 4 and 5. And after using modus ponens for 4 and 5, we have here not E. Okay? Not E. And then okay, E. This is an implication. E is the negation of the second part of the implication here. So what rule uses an implication as one premise, and the second premise is the negation of the second part of the implication premise? You will find there, you can use your modus tollens. Modus tollens states that P implies Q, not Q, therefore not P. Modus tollens. Go to your modus tollens. Again, your modus tollens states that P implies Q, not Q, therefore your conclusion is not P, or the negation of this first premise. So there is already a negation there. So you have not S, or not I. This is modus tollens of line number 3 and line number 6. Then, after using modus tollens, let's just use double negation. The not of not S or not I, this will simply be equivalent to not S or not I. Double negation, we just simplified the double negation of line number 7. So that should now leave us not S or not I. But what we have here is S and I. S and I. So how do we get S and I? Isn't it, to get an S and I expression here, we can use the De Morgan's rule. So that should now be the negative or not of S and I. So what did we use here? This is just using De Morgan's rule for line number 8. De Morgan's rule of line number 8. Then, after using De Morgan's rule of line number 8, where will we use that? Look at this. We have, in line number 2, you will find here S and I. You will find here S and I. This is or, and this is a negation of 1. We have used this earlier using disjunctive syllogism again. Disjunctive syllogism. Let's use line 2 and line 9. Disjunctive syllogism. Ano sabi sa disjunctive syllogism? P or Q, not Q, therefore, you get P. Disjunctive syllogism. P or Q, not Q, therefore, P. Disjunctive syllogism. So, our conclusion here, or our next line here must be not W. This is using disjunctive syllogism of line number 2 and line number 9. Line number 2 and line number 9. So that leaves us not W. Next, where can we use the not W? Where is that? In line number 1. In line number 1, W is the second part of a conditional statement. And line number 10 is not W. So using modus tollens, because this is an implication and then we are given the negation of this. So that should now give us, modus tollens states that P implies Q. P implies Q, not Q, therefore not P. Okay? Therefore, if we will now use modus tollens for 1 and 10, that should now give us line number 11. We negate this. We negate the first part of premise number 1. So that should be the negation of T or P. So this is modus tollens of line number 1 and line number 10. Then after using modus tollens of line number 1 and number 10, let's go back to the conclusion. What do we want? We have not of T or P. This is not T, the negation of not T or P, which is already the conclusion. Okay, so there you have it. There you have it for some examples on rules of replacement, rules of engagement, rules of replacement, rules of inference under arguments. Okay? So please always double check your emails. I'll be posting some exercises in your Google Classroom, some exercises that you can work with. So guys, again, I know that you are so busy with your other subjects. You are so busy with your Gen Ed subjects. But please, as I have mentioned to you, stick to your schedule so that every time I post also our video lectures, you will still find time to view our video lectures. Okay? So God bless you guys. So I'll be posting some exercises very soon.